In this tutorial we are going to be deriving suvat 1 to 4 from this straight line graph from different aspects of the graph. The graph we're using is velocity versus time, and it is plotted in the way that we assume a projectile will be to be able to apply suvat. So on this graph we've got u, the initial velocity, and v, the final velocity. We've got the time on the x-axis, and we have formed this composite shape which is made up of a triangle, a right angle triangle, and a rectangle. So this gives us everything we need to be able to derive suvat. So from our knowledge of motion time graphs, we know that the area under the velocity versus time is going to represent the displacement. We will use this principle to derive the S in the suvat. The second thing is the gradient. The gradient is of a velocity versus time plot, as we've said before, represents the acceleration. So to find the acceleration and derive it, we'll be using this factor, this gradient. So just really using just a bit of area, composite area theory of shapes, and the gradient of this line. So let's just put that into some sort of perspective. If we want to find the acceleration, just write that in really quickly. If we want to find A, that's going to be a gradient. Let's keep it simple for now. If we want to find the displacement S, the S is going to be all of this area under here, which should be fairly easy for an average mathematician because all we need to do is find the area. So first off, I'm thinking suvat 1, V equals U plus AT, just because it's fairly simple and it's got the acceleration term in. And we're going to try and use the gradient to derive this, which I'm feeling could be quite easy. So let's try this. So if we take the gradient of this line here, we would find the rise and the run and make a quotient or fractional ratio out of it. So the rise is going to be V minus U. Let me just write that in. So A equals V minus U. U has a stick on it. Okay, divided by the run, which is T. If we rearrange this, we end up with V minus U equals AT, and then we can get it in the same form just by looking at number 1, how it's stated, and make V the subject, and that just goes straight over there, and we end up with V equals U plus AT, and that is number 1 in a nutshell, using gradient.